Right, so yes, today's the final workshop of today is going to be around pair programming and code review. And we'll start off with a bunch of talk about code review, and then move on to some actual pair programming. Just a quick overview of what I'd like to talk about. There's probably a large amount of uncertainty as to why you would spend so much time, or indeed why we would run a workshop on the specific practice of reviewing other people's code. So I'll talk a tiny bit about why the actual important reasons you might be curious about that. Go over some examples, some different methodologies of approaching reviewing. I'll then do a sort of review along, where I've got an example change to a tiny Python file that I've already wrote, and I'll kind of pinpoint the things that I've not done fantastic and could be improved before merging into the wider project. And then we've got a couple of bits to talk about for code reviewing practices in open source. Things that you might have seen before if you've contributed to any open source projects. Certainly things that folks like Ryan, who presented previously, have implemented in their open source efforts in order to maintain good code quality and make it easy for contributors to feed back into projects. So indeed, why formally review code? Why spend so much time on something when someone has already written the code? And it looks good to me on a quick first pass. Is a fair question because it's time consuming and it's not what you're there to do. You're there to solve the problem, not to pick on other people's code. I'm making it sound like a bad thing so far, but the big case, especially if you're working on something that's highly collaborative, is having a second pair of eyes on everything that goes into your repository, into your project. You will catch issues much earlier. This isn't really talking so much about bugs, because there are many other project issues that may arise if you kind of don't vet changes a bit. In case someone comes along with a sort of huge feature to your compiler that adds some fantastic optimizations, but perhaps they haven't really documented things. And you fast forward 5 years down the line, you've now got a whole chunk of code that you need to maintain for your users because they're expecting that speed. The guys left town. Having some sort of process that means you can ensure that you've got everywhere. People understand where to find documentation and sort of a common code style for this sort of thing. Small things can help. Another big point is sharing knowledge. And this is, again, a big deal for having a large collaborative team, especially so if you're working remote. If you have team members working on some research or software project who are geographically distant, then it's even harder to end up. Well, you're even more likely to end up in, for lack of a, well, this is the software engineering word for it, but silos. You might end up with people who are kind of specialized to certain parts of your program, and to use more software engineering words, you end up having a poor bus factor. Because if someone responsible for an important part of your project kind of isn't available for that on a large or small scale, you can start. And it's a nice space, a kind of natural phenomenon that occurs when doing code reviews is that you have good discussions, often quite in depth, on things like code style and kind of meta things about code like style and documentation stuff, which often end up branching into more wide discussions about the actual change itself, and it can generally just improve your project quality. To be fair about code reviews, this means you spend a bit more time on maintaining your project. it's something that has to sort of it does take time, and you have to kind of I suppose respect the process a tiny bit, and without having some sort of I suppose experience in doing code reviews or seeing them happen, or perhaps even sort of looking at an existing project and seeing how they've done reviews and merging features from other authors before. You might not have a good idea of exactly what it entails and exactly what the good practices are. So we're going to spend a little bit of time today talking about those things. So in my head, I've been thinking about code reviews and the kind of two approaches to doing these in two different camps. On the slides is a website which gives you a bunch of example points as a sort of code review checklist. This is a solid example of like a really systematic code review where everything's kind of laid out for you in a manual checklist. And it's highly structured. This sort of thing, you might. But I'll move on. This is just a nice example of a certain way you can approach code reviews. Another way to aid in code reviews is to automate as much of the review process as possible. This is more or less me talking about the continuous integration workshop we had earlier in the week, where instead of sort of asserting that the author has run tests and has properly vetted their code for good documentation and style and such, you can enforce that by having some scripts, some workflows that run when they make their changes, and instead you can kind of check back on those logs and confirm, yes, all of the tests run. Yes, there's been a couple of tests added, or code coverage is still at the level that you expect, and so on. So depending on whatever service you might be using, there's different ways of automating your checklists, essentially. Alternatively, the other way I like to think of code reviews, and this is usually how I do it because I've never been too involved in a project that has a sort of a checklist approach, is you do a mental checklist of reading through all of the changes in this change set that you're reviewing, and asking yourself questions as you read through the code or the documentation. So it's things like, is this line tested somewhere? If you see a big function that's used lots in the rest of the change, you might go over to the tests and see, am I expecting a few tests for this, and are they present? Similarly, for code style, it's worthwhile to be fussy on code style for not just clarity reasons, but sometimes performance. I seem to remember in Python, you have to be a little bit careful for using for loops if you're trying to do numerics, if you're trying to do fast numeric operations, because they tend to slow you down lots. So it's not as if in that case the code is wrong, and you may well have good tests for that, but the code style would then poorly impact your performance. And it happens in the language of my expertise, Haskell, is quite terrible for that, because of some aspects of the language which might cause you to have quite atrocious performance if you don't put some consideration into code style. And you might not know that, which is where having a review process can be fantastic. And a little bit on kind of the Git side. If you remember on Tuesday when Dominic introduced lots of different Git commands and discussed good practices, and talking about even up to sort of commit messages and being a bit descriptive on that. Another part of the review process can be, are these commits, are they useful? Are they sort of self-explanatory or correctly separated from each other so that it tells a good story? It tells the story of the change that you're trying to do. A simple example would be perhaps, there's two different camps here. I was going to say separating commits for adding features and tests, but then some may prefer the vertical approach where you add one feature and all of its tests and then separately. But in any case, this could be all part of your review process, taking a look at the different commits and making sure that they're useful so that people can look through the review, the version history of the repo and understand what changed when. So, mental checklists in a sort of informal approach. Cool. So with that, let me move along to a little demo of some Python code I have, and this is a kind of, I'll intro I'll explain the tiny bit of the code when we get it on screen in just a sec. Sorry, that's my dog. So this is my change, but let's just open the repo for a sec to show what we're talking about. Okay, we have a little Python repository with a file called smatrix, which defines, and so far it's got just a few definitions with some explanation on what's going on. And oh, I should make this a bit larger. There we go. Pointer. All we have is a class smatrix. We're talking about symmetrical matrices and how we store them in a bunch of operations on them. Instead of storing them as sort of an array, we're being fussy about how we store data, which means we have to implement operations in a tiny bit different way. So far, there's not too much here. So I've made a pull request over here. I'm going to zoom out a tiny bit so that we can see more. That will do. I've made a pull request here to add some more operations. So this, did we talk too much about pull requests on Tuesday, Dominic? Do you remember?
Yeah, we looked at them. Yeah, we saw them and saw the things you could do with them, but we didn't.
Yeah, solid. So we looked at pull requests before, and indeed today we're going to look at them a bit more, and we're going to mostly we're going to look at the reviewing stuff that you can do on GitHub's website. It gives you lots of features, which means you can actually kind of do a review and have it all kept in history, so that you can refer back to things, and it's much easier to collaborate rather than sort of doing this over email or so. So this is my pull request so far. It says more operations. I didn't provide a description or anything. We have some CI, we have some workflows on this, and one of them is already failing. So I'm going to change to reviewer mode now. This was my change set, but I'm now changing to a different user called Benj Trees. Is this the one? Yes. Okay. I'm no longer Rayek. I'm no longer Ben Orchard. I'm Ben Trees, and I'm the reviewer of this pull request. So let me change tabs here. On the pull request UI, there's a couple of different views. And an incredibly useful view of a pull request is files changed. It gives you a diff view of everything that these commits, all of them together, change in the repository. So this is going to be your main way of, if you want to do your review on GitHub, there are other ways to do it because you can pull it down to your local repository and take a look there in your own editor and such. For now, we'll work on the GitHub website. And what's really useful about this is you're able to, if you look at the top right, there's a button that says Review Changes. Oh, that's too far. There's a button that says Review Changes, and if we scroll to any of the lines on this file, this is the smatrix.py file, there's a little button that comes up on the left. If we click it, let me just click on this first one, line 46 and 47. Then it comes up with a little prompt that lets you write a comment about that line, so about the change that occurred here. And I'll say for now, there's a test comment. On the bottom right, there's a start to review button. Click it, and we're now in like review mode, where we can add a bunch of comments on all of the changes in this pull request, and sort of just bundle them into a kind of review, which ends up being a set of comments, each linking to a certain part of the diff, a certain part of the changes of this. And then at the end, we go up to the top right, finish your review, and we add a final comment, which might be, and take a look at these 3 options here. We might ask just general feedback, and sort of neutral, yes, that's fine, or whatever. You can approve the changes with comments, or you can request changes and sort of request changes. Something that we've not done here is these can look slightly different if you configure your repository so that, I've not done this before, but you can configure your repository so that if a maintainer does a review for some pull request, they can actually prevent the changes getting merged a bit more explicitly, rather than just suggesting changes and such. So that can also be something quite useful if you're working on a project that is you've now opened to the public, and want to ensure clarity for adding and suggesting changes. So, as bench trees, let's discuss this pull request and take a look at the changes in it and whether they are sensible. How am I doing for time, Dominic? Are we about halfway through this?
Yep, halfway through your part. Yep.
Yeah.
So you're opening it up for us to review, are you?
For us to review.
As in, should we throw you comments?
Yes, go ahead. Let me scroll down to the interesting part. I've got some points. I've not written this fantastic. Actually, I've already admitted to a potential bug, actually a definite bug in this, which you can ignore or you can point out. I've got some points on errors I've made on this, but if any Python experts would like to take a look and tell me any ways I could improve this code before committing it to the code base.
Doc strings.
Doc strings from the audience. None of these functions actually have any explanation on what they do. I've got something called transpose alt, but transpose is at least a matrix operation that seems sensible. I don't know what alt means. It's not explained. Unflatten doesn't have any explanation. Yes, I think you're right, Chris. So I might start. We're in this review mode. I might pinpoint on transpose all and say, could you add a doc string here? We can add a review comment. This is now going to be batched with the rest of the things we're asking. Copy it here as well. So that's a very fair point, because otherwise, I kind of purposely made this a little bit unclear. I wonder if I can tab those down temporarily. Is there a thing on the left? There's not. Okay, that's fine.
More comments.
More comments from Dominic. Yeah, I think that's a very good point. There's quite a bit of indexing, and there's 2 checks that happen in the middle of this function. Clearly, we're doing some matrix operations. but it's not very well explained. And it also uses this unflatten function, and it's not very well explained at all. So let me ask. I mean, as bench trees, I'm not really too sure what's going on there. So I'll ask Thea also to explain a bit more. What exactly is happening here? Could you elaborate? Some comments. Okay. So,
are we being charged per letter for variable names?
That's a very good point. Yes, Jack, in a sec. Actually, yeah, Jack, please.
I was going to say, it looks like you said that one of those, that if statement's probably some kind of check.
Yeah.
So it probably shouldn't be a bear because if something's going to go wrong, you should probably catch whatever's gone wrong.
Oh, good point. Yeah, I've been a bad Pythonist here. Do you mean? Do you think I should wrap the array checks here, the array accesses with a try catch to make sure that they're not out of bounds, or do you want me to replace the if with a try catch?
Either, but I think it tries to get to a moment that says it's not immediately clear what that is. So it may be that statement is okay. So part of it might be just documenting, but if it is a test or catching errors.
Yes, I'll definitely admit that it's not clear at all. That perhaps we'll make that the first change that we request. Chris noted that I'm being too much of a mathematician here because nothing really is longer than 3 letters. Any of the variable names here, and we're no longer in the 60s. We have more than 5.3 for file names, and it's the same for variables. So I'll ask I think I'll put this in the general comment section in this review. I'll say, can you rename variables to be more descriptive? Yeah, I do that. Subconscious. I did that on purpose here, but I'm known to do that sometimes.
I'm going to be a voice from the 60s and say that I actually kind of like really short variable names because otherwise very long lines. You can have very, very long lines if you're expressing something.
You can break lines.
It's ugly.
A good point again. On variable names, yeah, it depends on the code that you're writing because this is a big code style point because this is a personal way I write things. This is a matrix library, so I'm happy enough to use M for the matrix that we're talking about. But then using L for the shape seems weird. I did that because I use it as a kind of length. But it's not the length, it's the shape of the matrix. It just so happens that it's the same. Since this is a symmetric matrix, it means it has to be square. So it's kind of the length. I do some transformation on the actual data store for the symmetric matrix, and then I just called it D because that was short for data.
I think one thing is, like, as a team, you want to come up with your code style, and you could also, in your code, have these are the conventions of this code base. Like, M is for matrix, D is for data, L is for length, and make that clear. And as long as you stick to that, I think that's pretty good. But a lot of these things, like, you should agree as a team.
Yeah.
I've got a question. So is code review a part of the onboarding process for new members to a project? To, I was going to say, introduce them or indoctrinate them into the project code style.
Naturally, it depends on your project and what you think is worthwhile for you. I think it's a very good idea to do a kind of some sort of highly directed code review for perhaps the first major change that a contributor makes to a larger project. Indeed, a nice example, and I've got a later example if we have time to have a look at an example, a cool an interesting set of changes to the GHC Haskell compiler with a bunch of comments between the author and a reviewer, and their process for new contributors is they have a ton of documentation which you can follow and understand what changes you should make where, how to format your code and your commits, and then when you actually submit the pull request, they're doing it on GitLab, but you can do something similar on GitHub. You can kind of pre-fill out, if I can show it quickly. Let me change it here. And if I say new pull request, let me just pick a random branch. Oh, will it give me anything? No, I've got to do it across. Sure. Is there a button on that? I can't see it. Okay, I won't show it here. But on GitLab and GitHub, you can write a special file that you keep in your repository, something like contributing.md, which it shows up to when you're creating a new pull request. It pre-fills the description with a bunch of information, and it's really common for people there to put guidelines for contributing to the repository. So back on the reviewer. Am I on the right one? Maybe. Hold on. I can't really see the. Oh, here we go. Yeah. Okay. A quick comment from me, Benj Trees. I keep saying that. It's my username on GitHub. So we've talked a lot about doc streams, and that's a big point for this. Something that I didn't like. I'm cheating here because I did this on purpose. I have this separate definition unflattened here. I'm going to scroll up, and I'm going to have to zoom out a tiny bit because I've got all of the. What? How do I zoom out on Firefox? I need to. Right. Yeah. In this, in the function I'm adding, I've got an unflattened function which should be explained a bit more. But I actually have another function up here. I have a sort of transformation I do on the data that the matrix is stored in, and that's actually that ends up being the kind of flattened partner to unflattened. And as a reviewer, I would much prefer. I think that is a useful operation for symmetric matrices to be able to kind of flatten it out into a single list. And I'm going to make the point there to sort of ask if they could refactor it out into a separate function. So just
especially because it's also a long and visually cluttered line.
Yeah, it's a kind of otherwise it's ugly. I had to do this reverse list thing. I'm not a great Python programmer. I couldn't figure out a better way to do it. Otherwise, I would be left with an iterator. Right, maybe we should wrap up the review there. So Ben Olshaw has a bunch of changes to make. I think we'll make a couple of these changes on the other side. But otherwise, thank you. Right, reverse changes. Okay, and just quickly then. Oh, I'll just quickly show what this looks like now on the GitHub side. We're back on the pull request view. And these are the comments that we left. It shows them on the related lines that we clicked. Let me move over then to my other window. I don't think I have the screen space to show both of these at the same time. So let's just make a couple of example changes here. This is slightly less important, but unflattened was my name for taking a list and the shape and forming that list into the symmetric matrix that it should be. So something like takes a flat list and a shape, size shape, and attempts to create an S matrix. The requested shape. Let me do that. And we'll go ahead and chuck this as well. I don't care so much about this step. This is less interesting. I'd like to show you what the pull request actually looks like on this side. So I'm just going to make that single change. I can't see the left of the screen. Here. Oh yeah, okay. I'll make that single change. I'll say a dot string. Latin function. Yeah. Okay. So if we go back on GitHub, I'm now back on the authors. View. Here, I'm back on the authors view of this pull request. So now it's showing me the comments that the reviewer just now, us all together, made on this pull request. It gives you a nice view, and it lets you resolve the conversation if you consider it to be complete on your end. If I click this, then on the reviewer's side, or actually on all other users, maintainers' side, it then shows unresolved conversation. So I suppose for now we'll just say, do I need to refresh? Since I made a change on the GitHub IDE just then, I've got another commit. We should be able to see the change that we made on unflattening. Good. Okay. So we'll say that's done. Add single line. Okay. Resolve. Okay, so in theory, we had a sort of short review session there. The author then went back and resolved one of the points made, and we have slightly improved code going into our repository. Right. I think let's move away from the GitHub stuff for now, and I'll talk a little bit more, show a couple more slides. Right. Yes. So just to make a couple more points about code reviews and open source, because this is kind of especially the case where code reviews they're much more prevalent, and they become often more important or more systematic. Have I lost? Did this just run out of battery? Hello?
Possibly.
Yeah.
Oh, hold on. It's flashing green and red at me.
Probably battery, yeah. Just have to speak loudly.
All right, no worries.
We'll use the hand mic.
I can do, yeah.
Let's put that on.
Easy, Chris.
Cool.
No, it's just turned back on.
All right.
It doesn't have a. All right. Well, okay. I'll move ahead. So open source projects are especially going to have often going to have more kind of rigorous code review practices. So I already mentioned the GHC Haskell compiler. It's really nice. It's just an immediate example for me. It's a huge project with 15, 20, 30 years of development behind it, from probably a few thousand developers, and there's lots and lots of interlocking parts. And somehow they're still able to make feasible sort of continuing process on continuing progress on this project with quite honestly very good, pretty good documentation and sort of understandability. So it's especially knowledge sharing becomes especially important for working on open source projects. Yeah, that's already something I've kind of pointed out. That and lots of kind of heavy automated testing pipelines are something quite common, and that's also incredibly useful to have to speed up your reviewing, so that you can kind of a first step of a set of changes to assert that they belong in the repository is to make sure it passes all of the tests and various pipelines that sort of get run for you. And we've mostly been talking about a kind of two-party code review, where one author does a bunch of changes, and then one reviewer comes around and comments on it, and there may be some back and forth, and it eventually gets merged. But for larger changes to more open, more complex projects, you may well have conversations with a couple of different parties. You may have sort of experts on different areas of the projects chime in on different parts of the project, and it's all in the spirit of better collaboration and better sort of maintaining. Yes. Thanks. Hello. Right. It's all in the spirit of better collaboration and better maintenance for your software in the long term. I think I'm almost done. There's one more point that I'd like to make on code reviewing, and that's that an alternate way of doing code reviewing is doing it on the spot as you're writing code, which is pair programming, is what I'm stating. So, if my time is more or less up, would there be any questions about the stuff I've introduced about GitHub's reviewing stuff, or code reviewing as a whole? There was a link previously if we'd like to have a quick look at some, if you're interested in looking at people discussing Haskell code in detail. No?
Should we go to the next bit and see how we go for time?
Okay.
We can always jump back to that.
Right.
Cool. Okay, so Ben's set this up nicely for the next part.
You might need to swap the single mic between the two of you.
Yeah. Oh, I can't type if it's that high.
So, do you need a spare? Or would you like to put your laptop here?
Does anyone know if this is actually adjustable?
Oh, somebody used it in the morning. Is that laptop or first?
It's all right. I'll just go elsewhere. No, I can give up on that one. Yeah, I'll go over here, please. Yeah. Okay, so let's move to this different part and move this bit here. So Ben mentioned this idea of pair programming. Does anyone know which computer is in this photo? Any guesses? Okay, it's the ENIAC computer, one of the first computers that was ever built, possibly the first. No, it's not. It wasn't the first, but it was the first one in the US. There's two people here. One of those is Jean Bartik, who was one of the first programmers in the world. She said this: Betty Snyder and I were from the beginning a pair, and I believe that the best programs and designs are done by pairs because you can criticize each other, find each other's errors, and use the best ideas. So right from the beginning, these intrepid computer programmers were doing pair programming. That's when you work together with someone else to get your code done, to do the task that you want to do. And as Ben mentioned, this is also an approach for doing code review that's sort of on the fly, on demand, having someone else there who's kind of looking at what you're doing and making suggestions as you go. So this is cool because these pioneers invented pair programming, but it wasn't until the 90s that this really became a concept that was sort of publicized. Ken Beck came up with this idea of, was one of the people who was a proponent of the agile programming methodology, and pair programming was a big part of that, this idea of working together in a small group, 2 people, to get the task done. So there are a bunch of different styles of doing pair programming. We're going to talk about those. There's sort of 4 techniques that I'm going to describe. We're going to demo 2 of them as well. And there's sort of ways of organizing this activity. I think it's, press the magic button, the ejector seat. This is the kind of joke, right? 1 + 1 is greater than 2. Not quite sure, it's like 2 people programming separately and 2 people programming together, and that's the better thing. So why is it good? You get knowledge sharing. Right? When you work with someone else, you always learn some new things. And it sort of puts this reflection in the loop, right? If I do work on my own, it's really easy to just be like, yeah, I did it and it was great. That code was amazing. And I've got no one to sort of say, was it? What about this? Or even just to sort of make me stop and think. So it increases reflection. And it also, as we'll see in some of the styles, gives us different ways of thinking. If you have 2 people, you can sort of do 2 different things at the same time, think in 2 different ways, have 2 different modes of thinking between the 2 people. So it also requires a lot of communication and taking care while you're communicating as human beings and agreeing on what you're going to do up front. So we'll see some of the techniques and we'll do some demos. So one of the main techniques is called driver navigator. So you've got 2 people, one person is the driver, the other is the navigator. The driver is the person who's writing code. So they're the ones with their fingers on the keyboard. That's how we usually think of the driver. And the navigator is someone who's then considering the sort of wider strategy of the code, thinking, where is this going, giving comments about how to do it, and the driver is the one who's writing it down. A big part of being the driver is also verbalizing. For many years, I did the admissions at Cambridge, so interviewing prospective undergraduates, and it's a very terrifying thing for them, not for me. You set them some sort of maths problem, and you say, okay, solve this problem, and what you want them to do is verbalize what they're thinking, because that lets you sort of understand their thought process and kind of actually get a window onto that person's problem-solving skills. And it's a bit like that here. You need someone to sort of verbalize what they're doing. It sort of slows things down, and then it's a chance for that dialogue. You need to have a goal agreed at the start, so that the navigator knows how to navigate. You need to know where you're going. And there's this advice to the navigator that they should not be too quick to pass judgment. When we are coding, we make mistakes all the time. You've made a mistake. You don't need the navigator saying, hey, that's not how you spell the word for. Because maybe you've noticed, so 5-second rule, wait a little bit before jumping in. And this particular technique is really kind of like code review on the fly. This is really a good chance to be doing that code review. The navigator is looking, thinking carefully about what's being done. Okay. Right, so we're going to do it. Keep an eye on the time when I do it. Just grab my phone. Yeah. Hi Ben, how's it going?
I don't know. I'm good.
Good. Oh, thanks so much for agreeing to pair with me today. I think that'd be really helpful. As you know, I'm still a bit of a Python novice, so I think it'll be really useful. So I was thinking today that we'd look at this symmetric matrix package, and I was kind of hoping to add like a function that makes identity matrices. Think that sounds okay?
That's a good point, yeah.
Could we do sort of driver navigator? I'll be driver, you be navigator.
Okay.
Does that sound okay? Okay, I think that'd be really useful. And I don't have a lot of time. I've got a meeting to go to, so maybe we've got about 10 minutes. Let's see what we can get done. Okay, so I've looked at this code a little bit. I think I know how it works. And we want to make this identity function. You know what? I was in this training about Git, and they talked about using branches. So I should make a branch for this new feature, I think, right?
Yep.
What should I call it? Identity. Now, oh dear. I don't know what those are. What does that mean?
Oh, I should look at this screen.
I think that means I did some changes before, but I did git diff. It just looks like I was looking at the comments. I think that's fine. So I reckon we should do some tests. I heard about that at this summer school as well. So let's do some tests. And I can see they've got this, we've already got this test thing in here. And I want to make identity matrices. So I'm going to add some tests and call it test identity. So, I don't know, I kind of need to visualize this, like identity matrices, like they're going to look a bit like this, if it's a size 2, isn't it?
Yeah.
So, let's pretend we're going to call this thing identity, and I want to assert that it has, I think it should look like this according to the scheme of the other tests. Actually, I kind of like those tests, I might steal them, put them down here. Have some different sizes. That's always a good idea. I think that's called systematic specialization. Okay.
Right, that's sensible, yeah.
What's this all about? Oh yeah, I think that's supposed to be an equal sign. Okay, that looks happy. Right. So I'm going to put my code in here. I guess we want the shape. Now I also heard about this thing called doc strings. Sounds like that would be useful. Now I can put some stuff in. They've got some useful things here. Now, let's have a look at this business down here. So I know I want to make a matrix, and it's going to have some shape and some data. You have to make that stuff. I've got the shape, so that's good.
This will probably look similar to the zeros function.
That's a good point.
Yeah, there's the snippet that the list comprehension that builds up the data.
Mm-hmm.
We might be able to start with that and then kind of change it so that the relevant cells become 1 instead of 0.
So those are all zeros. So I just see if I've got enough stuff to actually run the test. Let's see what happens.
Well, I was going to say, can you use the ID? ID might be a keyword.
Oh.
Python, I'm not sure. So ID.
I guess we'll find out. High test. Okay, well stuff ran, so that's good news.
Assertion error is good, yeah.
Assertion errors, okay, so it was expecting, well it was doing 0 equals 1, so that's, that's kind of what we want. So looking, it's like a two-dimensional comprehension. I think what I could do is add a 1 in the front. I've actually forgotten how to concatenate two arrays, 2 lists.
Double plus.
Double plus. No, that's Haskell.
Oh.
There we go, single plus.
Single plus.
There we go.
That's weird.
And I guess what I want to do is reduce the size of this thing, so I can go, instead of going 0 to row size, I think I can go 1 to row size. I don't know if that's really going to work. I kind of want to try it out, so I'm going to copy that down here. Look at shape 2. Whoops. Hey, that looks pretty good.
Okay. Yeah.
Okay, let's run the test again. Ah, doesn't look good.
Have you saved the file?
I don't know.
Yeah. Okay.
Yeah, it still doesn't look good. There's definitely a problem with the 1 case. Oh, you know what? I think I might have a problem with my test. Let's check. I did zeros here.
Oh, we hadn't updated the name yet.
Cool. Okay, so that's good. What else should I check about this?
I'll say you may want to check size 4 matrices. This seems pedantic, but in the previous changes I made to this repository, I ended up writing something that didn't work for matrices larger than 3 because I didn't test it on matrices larger than 3.
Okay, I'm willing to do that. More tests is always good, I hear. Okay, that looks good. I think there's a coverage checker here as well. Cool. So 95%. That sounds okay for now. Okay, so I think we're okay. I'm going to commit that now. That looks like all the changes. What should I call this? Just stuff. That's a really good commit name, I think.
Well, have you added the test and the source changes?
Oh, I don't know.
I think we should
Git status. It says I modified both of them and they're staged. So
yeah. Okay. Good.
okay.
Yeah, we should bundle them together here.
Okay, that's a good idea.
We could say something like add identity function and tests, or we could be a bit more. Oh. We could explain git commit amend here. If we want to be a bit more explicit, add S matrix identity function.
Okay.
So that people know exactly what we're talking. I suppose if you look at the GitHub sort of ticker for changes, it's now even more explicit.
Okay. Yeah, I like that idea. Okay. And which branch am I on? So I'm going to push that. It wants me to do this thing. I'm just going to do what it says.
Yeah, that's just what you have to do to set up a new branch in order to push it.
Oh, thanks. Okay, so I made a PR, and did I? No, I made a branch. So I can go to my branch, and maybe we'll get someone to review it. I think we've had a nice session, but
get bench trees.
Yeah.
Sorry.
That guy's good.
I'm mad that the name didn't show up. Try Rayek with an E on the end. Oh.
Let's go for this guy instead. He sounds pretty switched on. Turns out I can't type, but okay, I think that's good. Oh, well, thanks so much for pairing with me. That was really useful.
Yeah, of course.
Thanks.
Anytime.
Yeah, I think that was good. Okay, and MC. Okay, so that was pretty smooth, but it was useful to have someone else helping me think things through. And Ben was pretty kind to me. He didn't jump in when I made sort of silly mistakes. He was pretty sort of careful with letting me go on a bit, and then he fed me some useful ideas as we went on. So that's Driver Navigator, and that's probably the sort of most popular, most commonly used approach. It's like this code review on the fly kind of idea. It can be really nice if you've got someone new to the team and they do the driving, and if you're the experienced person, you do the navigating. You can help explain things to them as you go. But there's some variants on this, which we'll see. One of the things that's kind of nice about this compared to the kind of code review that Ben showed before is that we're getting it on the fly, and it's sometimes easier to make suggestions about kind of small stylistic things. If someone gives you a load of changes to review that's 500 lines, you're sort of less likely to go through and pick up loads of tiny little things like maybe you should put a different variable name here, maybe you should put a comment here. The larger the change, the stronger the temptation to have less fine-grained feedback. But when you're pairing, it's easy just to say, oh, how about we call it this? Okay, so I didn't fix my slides. Never mind. A variant of this of Driver Navigator is Driver Observer. In this mode, the non-driver person is sort of more passive. They're kind of more just there for the ride, kind of taking it all in, trying to understand what's going on, and they might ask questions like, well, why is that happening instead? So I think this is really good when you've got a new member to the team, or you're working with a student, or just someone who's less familiar with something. So it's a nice way of teaching them something by letting them observe how you do it. And you can sort of learn a lot that way. So that can be a really useful approach for onboarding people. Okay, here's another style. It's called ping pong. Again, it's two people. The first person does what's called a ping, where they write a test. The other person responds, pong, by writing the code to match that test, and then you talk together about that thing and whether it's a good implementation to match that test and whether any refactoring needs doing, and then you switch roles. And so the person who just wrote some code now writes a test, and so on and so forth. So you're sort of alternating between who's doing the typing, and it's you each taking it in turns to write tests and code. All right. Take two. Hi Ben, how are you?
Hi Dominic, I'm a bit exhausted from a review session, but
Okay. Yeah, I stayed up really late. I went to some pub. It was great, but yeah, I'm getting old. But it's all good. So thanks so much for agreeing to do some pairing with me today. I was thinking we'd do ping pong. Is that okay?
yes, okay.
Could you be the ping first and write some tests?
All right.
So our team lead said that we needed to add more stuff to this symmetric matrix code. I think they wanted us to add some operation for like adding up to symmetric matrices, which probably sounds like we could do that. But yeah, let's do that, and you can be the ping and write some tests first.
Okay. Well, I'll continue on some similar work that some previous folks have done, adding some tests for this identity.
Oh, I like those tests that they've written. They've really thought about that.
I won't do any copying here. I'll just make my new one. So let's say I'm not writing the implementation yet, but I suppose we're writing matrix addition.
Yeah.
So we're already in a matrix package. I'll just say test addition.
Yeah.
And let's say that this, I'll assume the name and the signature of this function. Let's just say it's addition, and we're going to be asserting.
I think we should call it add.
Add is better?
Yeah.
Should I do the same for the test name? Just to make it a bit clearer.
Yeah.
Okay, so we're going to be asserting something about an add. This is going to be taking two matrices, so we'll say m1, m2 equal to, yeah, and then we'll say equal to, sure, m3.
Okay.
And then above, we'll assert. Perhaps we make this simpler. We think about, oh no, we only have we have to define that third matrix so that we can have something interesting. So let's say, let's do a couple of let's create a couple of matrices. That's the S matrix class. So in it takes an int for the shape, and then a list of floats. So that's I've seen that data. I've seen that before. Let's say.
I really like how they added types into this as well. It's good documentation.
Actually, yeah, that was useful. Let's keep it simple. We'll say that m1 and m2. We'll just use the identity. Well, maybe let's just add. This is much easier. We already have 0 as an identity. So let's just add the 0 matrix to the identity matrix.
Okay. Yeah.
So is that do? I don't have to. Oh, I've got to qualify it here. So S matrix 0, 0 or zeros. What the other one is?
I think it's zeros. Nice.
Zeros. So we'll do the 2 size. M2 is S matrix identity 2. So M3 should be M3 should be. I think we'll have to make our own one here. Let's make a new S matrix. If that's how we do it, or we have to.
Well, if we're adding zeros to the identity, we could just get the identity back, right? So
yes,
we could
right.
just change this one to be M2.
Okay. I think I'll inline this because it's a bit over the top on the syntax. So
that looks like
zeros
a test.
identity add M2. Cool.
Now, just thinking about that equality, is that going to be pointer equality on those like objects, or is that?
Yes, you're right. I suppose we've already done the correct thing here with data. So
Okay.
if we check the data that they're storing instead, that should be a bit better. I think I'll also add a little temporary add functions so that we can just see if this compiles.
Oh, how nice.
Is that worthwhile? One M2, and we'll return. I'll just return M1. That doesn't matter.
Okay.
So then.
So we can smoke test it, make sure it doesn't catch fire. Call fire.
Oh, did I save? Oh, yeah. I've got to do more qualifying.
I think you called it S-add and it's actually add.
Yeah, I'm sorry, it's add. Oh, I'm trying to control. I'm trying to save the file. Sorry. Okay. Oh, I keep trying to save the file with the wrong button. All right, one more time. I don't think I have to save.
Okay.
This is better. Assertion error.
Okay.
Okay.
All right. So I'm going to pong your ping. Thanks for adding that test for me. So I think I'm going to start with the doc string. Now, as I was writing that doc string, I started thinking you should probably only be able to add matrices that are of the same size. So I'm going to say if m1.shape equals m2.shape, then we're happy. Then that's going to be good. Otherwise, I'm going to throw some kind of error. I'm going to throw a runtime error and say.
So it cannot add matrices of different size.
Good idea.
Or symmetric matrices, perhaps.
Yeah. Well, that's also true of all matrices.
Fair enough, generalized.
And I could add some more detail in there, but maybe we'll do that another time. So I'm going to put a to-do in and say, I always like error messages that have more info, but let's stick to the task at hand. Okay, so if they're the same shape, then I think I can do some sort of zip operation, like I can do zip M1 data, M2 data, which is going to give me like a row 1 and a row 2 inside of here, and then I want to zip those two things together as well. So if I say it's, I'm going to call it LM1 and LM2 in zip row 1, row 2. Oh, I don't know if this is really how this works. I think I might need to refresh my memory about zip. Yeah, okay, that looks like I got it right. That's good. But it's a bit unhappy about this. Probably. Oh, I know why.
Are the brackets? You need to bracket something.
Yeah. Like this. Oh, and now this is creating some data. So now I can make a new S matrix with M1 shape, which I've established is the same, and with some data. Well, I'm not super confident, but let's run a test. Okay, that passed. Great. So I think that was a good test and it worked, but I think we should try some other tests. So I'm going to ping now, and maybe let's add a comment here that says A plus I equals A. But we did it with zeros. You know, maybe we should do it with something that has some more data to it. You know, what we could do is add two identities together and check that they come up to 2 in the elements.
Yep.
Let's do it like that. And then when I add these, I guess I want it to look like. Oh no!
That's for a three size matrix.
Yeah.
There you go.
Yeah. And then we can go from there. Okay. Let's end scene there. Okay, so so that was ping pong. We're sort of taking it in turns, thinking about this problem together. Test code, test code. The test that Ben wrote I thought was pretty good, but I had already started thinking of some other tests, but I didn't like jump in. I let him just do one test. I wrote some code, and we can write some more tests. If the code already passes the test, then we can just keep pinging, keep adding some more tests until we're happy. So last two techniques. So strong style is when you've got an expert navigator and the driver is a novice. So this is like another variant of driver navigator, but it's a kind of learn by doing approach where basically the navigator sort of tells the driver exactly what to do sort of the whole time. So it's like the navigator is programming, but not by actually physically doing anything. So there's this sort of maxim of, for an idea to go from your head into the computer, it must go through someone else's hands first. So you're sort of verbalizing as the navigator exactly what to do, like, okay, make a two-dimensional list comprehension, and you should go from row 1 and row 2, you can get them out of this zip iterator, blah, blah, blah. And so it's a sort of, it's really it's a sort of more intense version of driver navigator because you're really verbalizing so much stuff. It's like you're teaching someone, but you're not writing code yourself. And I think this is really true for all of the styles, but especially with strong style, you want to follow that up with a review and actually talk about what you did. Especially if the driver's really a novice, they'll be thinking, well, why does that work? What is this zip thing? So the review is a chance to really talk it through and make sure that they've understood everything that's going on there. So it can be, and again, it can be really useful for getting people on board with, if not, it could be a project or even just like an idea in a project. Like say I've got a student and we want to achieve something new in our code base, but it's really complicated and I know they don't know a lot about it yet, then we can do this strong style as a way of doing knowledge transfer. But we won't demo that. And then the last one is pair development, which is a much more kind of balanced approach. Sort of usually works when people are at a sort of similar stage or similar sort of maturity or awareness of the problem involved. And it's really good if you're doing something quite large, perhaps. You sort of sit down and actually design something together, so plan it out with maybe diagrams and paper and documentation, thinking, okay, there's this big thing we need to do, how are we going to design it? Then you do something that's a bit like the driver navigator, but you're sort of alternating quite a lot who the driver is. And this is typically in a sort of longer, you might do lots of sessions, you might break for a little bit of time, maybe do sort of 20 minutes, half an hour, and you say, okay, let's have a break, do something else. Or maybe you need to break because it's like, we don't really understand what's going on here, we need to do some thinking on our own. I often find that I do my best thinking sort of after I've talked on for a bit and I go and just sort of hide in my cave, sort of stare at a whiteboard, drink some coffee and sort of think for a bit, and then I can have some ideas, and it's much easier to do that on my own. But so this is like a sort of extension of Driver Navigator for these bigger things. So this is sort of balanced approach. Okay, so those are the sort of 4 sort of classic techniques. I'm sure there are others out there. You could probably do a bunch of Googling and find some sort of other styles, but these are the sort of commonly discussed ones in sort of software engineering courses. So some thoughts then about pair programming overall. So one thing that's good to avoid is micromanaging. We talked about sort of being as a navigator, just sort of staying back. It's always annoying to be micromanaged, so just avoid that. And I think short bursts are good. They can be exhausting kind of sessions, can be quite tiring. I know maybe some people don't find it tiring, but I think most people find that kind of level of interaction difficult beyond, say, an hour. Some people advocate for the Pomodoro technique, whose time I forget. I guess it's 25, is it? 25? Yeah, that's what it says on there. So that's like, you set a timer, you go for a certain amount of time. In the demos that we did, we had some quite short tasks. They took about 8-9 minutes. But I had said at the beginning, I've got 10 minutes for this. And I set a timer. And that could be helpful as well, saying I know that I can only sustain it for this amount of time, maybe because I know I get really tired after 10 minutes, or maybe because I have a meeting in 10 minutes, or I need to go do something else. So having that kind of agreed up front, I think is really useful. Consider physical space. So Ben and I were physically together. Did you feel like I was in your space when you were typing?
No, not at all.
No, you're happy with that? I think this is really important to consider, right? If you're in someone's office, maybe you're crammed in. We've got a lot of space up here, right? But if you're sitting on desk chairs, which are you've got the big arms, you might want to think about that, especially if there's, different sort of power dynamics at play, professor, student, and so on. Just think about, is everyone comfortable in this space? If you're doing it remotely, actually pair programming is pretty nice with remote. We've been doing remote for a while, that can be really nice there. Except I find the temptation is to just get distracted and sort of like, oh yeah, they're writing some code, I'll just check my email. Oh no, disaster. Oh, no. So that's a bad academic approach there. So yeah, have a think about that. And communication is really important here. Having shared goals, having the understanding of the role. At the start of both those sessions, we sort of agreed up front what style we were going to use, who was going to do what and when, and we kept communicating, we kept verbalizing through that time. And then afterwards, as a team, you can reflect, discuss, and adjust your process. Maybe if you're integrating these practices in your particular research group or particular software team, you might want to discuss, are we finding this useful? Do we need to try some different techniques? Do we need to do it shorter? When do we want to do it? Do we want to do it all the time, or do we just want to do it at particular points? Should we use it in an ad hoc way when we're trying new features or when we're trying to upskill various parts of our team? I think key is always just having this reflection and discussing. I think some people get really into this idea and say we're only going to do pair programming. We're going to do it 8 hours a day. I think that probably rarely works, and I can imagine that people might hate that. So it's good to have a discussion about that as a team. And I think I probably don't do more than an hour's pairing a week, but then that's me. So your mileage may vary. Okay, so I think we're pretty much at the end of what we wanted to say. Is there anything else you want to add, Ben?
No, I've had some experience doing pair programming in the workplace before, and similarly.
You mean in industry,
This was in industry. I was, and in particular, the problems we were most working on. It was usually something that neither of us had much experience about. So it was largely for knowledge sharing, and it was we essentially did the sort of driver navigator setup. Where usually I would be driving, but they were my senior, but usually I would be driving and kind of pointing out things I'd found links and stuff, and then had a go at doing things. And it was largely a practice of sort of verbalizing and discussing our sort of plans and thoughts on how we would do things and how we would use this kind of stuff we were learning about. So I've had a good experience with it before.
One sometimes I found it really helpful is if there's something I've had to do, something I've needed to get done, but I've been really struggling to get that thing done. Maybe because I'm kind of terrified of that task, or I tried to do it before and I failed, or something about it is not working for me from a motivation point of view. So saying to someone hey, could we pair on that and do a session for an hour? And try and make some progress on it can be really good, because it's just it gives you this additional focus. Having someone else there helps you to focus on it, and then it's those multiple modes of thinking, isn't it? It's having someone else to say, oh well, why do you think that, or are we sure that that's how it works, or maybe I don't know, I don't understand that, could you explain it to me? Sometimes the best way to try and understand something is to explain it to someone else, right? Often you find that when teaching, it's in order to teach something you have to really understand it. So that can be helpful too. Okay, I'm going to explain it to someone else on the team, even if that person is a rubber duck, right? There's this idea from software engineering of rubber ducking. It's when you sort of talk to a rubber duck and you're just trying to get your thoughts out, and as you do it, it helps you to sort of think, yeah, that's how it works. Just sometimes verbalizing it is helpful. So you could ask one of your teammates to be a rubber duck, but probably they're more useful than a rubber duck. They might say, what do you mean by that? I don't really know what that means. Can you really add symmetric matrices of different sizes? Can you transpose a symmetric matrix? What does that mean? And so on. Okay, so let's open up some questions.
Do you do more than 2 people? Like, have you experienced doing backhoe with more than 2 people?
Chris, do you want to answer that? I think you had a funny way of describing that.
Mob programming.
Mob programming.
So I've heard it described. We got more than 2 people.
Yeah, I think mob programming kind of sums it up. Have you ever done it successfully?
No, not that I've, no.
I mean, I think it, yeah, I feel like it's...
Sounds like a meeting.
Yeah, it sounds like a meeting, yeah. I think it could probably work with 3 people. Yeah, it might be fine with 3 people. I think the more people you have, the more redundancy there might be in terms of what you're getting out of it. If it's really like, as a team, we need to understand this thing, we need to do it together, and it's a kind of like, basically like a meeting where someone's explaining something to someone, then I think that's probably okay. And I've definitely had things a bit like that with my research team, where it's like, there's this new thing we're doing. Like someone might explain a feature that they've added to the code to the team, but it's a different kind of thing than like, I'm going to sit here and like write code. I think it can be done, but I would say be careful beyond 3 people. Yeah, Joseph.
Thank you very much. I find it very interesting and tricky at the same time, because if you're in a situation where you are working on a unique stuff, and for instance, if I'm an undergraduate or a master's student with some classmates who are exposed to the same kind of project, or we're working on the same kind of stuff, it would be easier for me to find someone with whom I could pair.
Mm-hmm.
Yeah, I think my situation would be more of like rubber ducking or something, because so I just go to the office, I sit on my desk, I'm looking at the laptop like that, and then I'm trying to wrap my head on how to crack certain codes. So how do I find a suitable pair?
Good question. How do I find a suitable pair? Is the question. It depends what you want to get out of it, and it depends sort of what technique you want to employ. If the pair is there to really just be a rubber duck, then there are lots of rubber ducks out there. They maybe don't need to know that much, but a bit of technical background is probably useful. If you're wanting someone to be able to sort of feed you input and sort of help you do it, like the strong style or the driver navigator, even to some extent, then yeah, you need someone who has some technical skills, either in the language, because maybe you kind of there are different things at work, right? Maybe I have an idea of how to do something, but I'm doing it in a language that I don't know. Then I just need someone who knows that language, like Python, but maybe they don't need to know anything about the problem. Or maybe it's the other way around. Maybe I'm really great at Python, but it's this problem that I don't really understand, and I need to find someone who knows a bit about that. So I would ask around your team, try and find someone who's aware of those things, whether it's, I would identify what's the thing that you need out of it, I suppose, is one thing. There's a question that we thought of when we were preparing this, which was, how do I get a pairing session with a member of ICCS, with a member of the core team? Well, you're part of Lemon Tree, right? So you just send us an email and say, I'd like a pairing session about this, and it's going to use this language, and this is what I'm trying to do, and this is what I would like out of it. And then we can go to our team and say, okay, who knows about that stuff? So yeah, do drop us an email. And there's tomorrow as well, right? There's tomorrow, we've got the hackathon. This session is kind of giving you some of the tools you can use at the hackathon, because you're going to be working together in teams. So it might be, 2 people are going to work together on doing a particular thing. I've been at hackathons before. I remember when I was a grad student, I'd been doing some work and I knew theoretically how to solve a problem, but I had no idea how to implement it. A guy I knew was really good at implementing that kind of thing, and we were at a hackathon, and basically we did a sort of driver observer. He was driving and there was me and someone else who were observing, and well, we were sort of navigating because we knew the high level. So we were sort of saying, like, this is how you solve this problem. How do we actually implement it? It was working on a compiler. And he went through and he did a bunch of stuff. And it turned out, yeah, that now is in a production compiler. We did about an hour or two at the hackathon over different sessions. And then he went and finished it later, which was great. But yeah, sort of, it works at a hackathon level as well. I didn't write any code, but I believe I contributed to getting it into the compiler because I knew the high level side of things and he knew the low level. So yeah, so looking forward to seeing you all practicing some of this tomorrow. And I will go around and be there to offer advice and to any answers to questions about procedural things. Yeah. But I would always encourage people to just try things, right? Just try it out and see how it goes. Just like with programming, right? I'm there writing Python code. I used to write Python a long time ago and I've forgotten most of it. And then I go, how does this thing work? What do? I try it and I tinker and I drop into the REPL and go, is it like this? Oh yeah. So work it out by trying. Cool. Any other questions? Orly.
What about doing something iteratively, like not in the same room, but I do something and I pass it to someone? It's like more delayed in time, but you have time to think about it maybe more deeply? Yeah,
I think so. Yeah, question is, what about things that are like time delayed rather than being together? I think that kind of goes to Ben's, the start of this workshop. Like that is a very, very common and good way of working. That's essentially like working in close collaboration with someone, but it's kind of asynchronous. Pair programming is very synchronous. It's really like at the same time. It's the 1 + 1, the plus meaning at the same time. And what you're describing is like the kind of good kind of close collaboration that's asynchronous, which is really valuable as well. And I think I do that probably the most because you've got people in different time zones, different working things, different meetings. Finding some time together is different, but that kind of close, you do something, I do something, and you can apply I think you can apply some of these ideas. Like you can do ping pong, but you can do it asynchronously. Like I wrote this test for you for this thing that you want to implement. Hey, I implemented it. Okay. I've written another test, so you can stretch these things to the asynchronous mode as well. Yeah, the thing is about having strategies for collaboration really at the end of the day. Good question. All right, I think we're getting to the hackathon pitches session now. So yeah, cheers Ben.
Thank you very much, Dominic.
Thank you. Okay, so we are on to the hackathon zone now. So, right, what is a hackathon? Hackathon is a chance to write some code together and make something, right? It's a creative time, working on a problem together as a team, and it's a great opportunity to learn some things from each other, whether that's like domain stuff in science, or some programming techniques, or some how to use this library, or how to use this language, or how to do pair programming, or how to do testing, and so on. It's a great chance to learn from each other in a short time, have some fun, a low stakes environment. You don't need to do this for your job. It's just a chance to have a little bit of fun working together with other people and networking as well, right? Meet some people who you haven't met before. So the way that we're organising things is that we've got a few people who are going to pitch projects. These are project ideas for things to work on, and then tomorrow will be the work. We'll be getting things done. So we'll be in the computer lab tomorrow, the William Gates building, and those who are at the summer school will be walking over 8:15 from Jesus, and there'll be taxis as well. We'll start at 9 in FW26. I'll update this later, and we'll just have a little quick settle-in session. But the idea is basically to just work on things throughout the day. There'll be tea breaks, there'll be coffee breaks, there'll be lunch, and then we will come together at 4 o'clock, and each one of the groups will do a short presentation, sort of 5 or 10 minutes, about what they've done during the day and how they've done it. Then there'll be a short break where the judging happens, and the judges deliberate about the projects, and then there'll be a prize giving session, and then the closing remarks for the whole summer school. So groups, we're hoping that groups will be, well, basically anywhere between 2 and 10. I think we don't really want to have groups bigger than 10. It gets a bit difficult. I think probably, what would you say the optimum size is, Chris?
4 or 5.
4 or 5, yeah, I agree with that, yeah. That's a good number because then it's easier to collaborate. So in your team, you don't need to all have the same skills. Probably it's good to not all have the same skills. And maybe you go into a team that's using a language you don't even know. That's also fine. You can still contribute in lots of ways. Maybe to the process or the documentation or the understanding, or you'll learn some things along the way. So how will these be judged? There are 3 criteria. One is software engineering best practices. So during this week, we've learnt about code. Well, we've learned about a lot of things, but we've learnt about version control, pull requests, branches, all these sort of organizational things for doing collaborative code review, pair programming, CI, testing, documentation, good use of communication via things like Git issues and commits. So one of the criteria that the judges will be looking at is sort of software engineering best practices on some sort of scale of 1 to 5. And 2 will be the sort of the impact of the project, the sort of like, kind of, has it achieved its goals? Does it have some sort of benefits and contribution to some sort of area of science or engineering or some people's work? And the last one will be a sort of a quality measure. How well does it do what it has aimed to do? Does it, is it a good quality piece of software that works, is robust, and sets out to, and actually achieves what it set out to? So that will be roughly the criteria. So as you go on, you can think about those things like, hey, how are we actually doing this? And so in the presentations, I'll be asking you to say a bit about how you organised the software engineering aspects of your team. Anything else I need to say about those things, Chris?
I think that covers the judging, certainly.
Yes, okay. So let's move on to the pitches then. So I don't know how many pitches we've got so far. I think we've got at least 3. So 4?
I've got one still to submit that I'm just running.
Okay. Who wants to go first? Simon, could you go first?
Yeah.
Great. And I'll write it down up here.
You want to stand up in front and grab the mic?
Are we in shot enough on this, Chris?
We're actually the only people in the meeting right now, so it doesn't matter.
So, as I'm sure you all remember from Athena and my talk on Wednesday, I talked about the Fortran TensorFlow interface, and I mentioned that there's going to be a script that takes a TensorFlow model and processes the necessary information out of it to generate Fortran code, which you can then use to load with the model. And I said that that script was a work in progress, and Dominic helpfully suggested that I offload some of my day job into the hackathon. That this might be a very useful idea because it's relatively enclosed, it's relatively encapsulated in concept. So the script is written in Python. There's about half of it written. The output is Fortran, so we need something that can actually generate compilable proper Fortran. There's an existing repository, so I've just sort of cloned that up, and I'm just working that up now. So if you have a knowledge of Fortran, that would be helpful, but not required, I think. And certainly you don't need to know anything about TensorFlow, and Python, I think, is kind of pretty obvious anyway.
Okay, sounds good. So I think we're calling this one process_model, unless you have a snappier title.
That's it, isn't it?
Process model _model.
That's the name of the script.
That's the name of the script. So that's the team name now. And so that's sort of going to involve Fortran, although not actually writing it, Python. Kind of something a bit about TensorFlow, I suppose, in a sense. You don't need to know.
You don't need to know about TensorFlow.
And
I'm saying you worked on a TensorFlow project.
It's worth mentioning that from here, that particular contrast of chalk or black
Yeah, I was going to say,
is fully invisible.
I can't even see it from here either.
Isn't there a light though?
Oh, did we turn that? Yeah, we turned that off, didn't we?
I think you might need to do it on the interface on the lectern.
Did this light break?
This is just the lectern.
Oh,
No, it's
on
those
the-
lights.
I don't know if it is, but the pointer stick might have been trapped or something. It made a sound. Oh no, good stuff.
Something was
No, it was me turning it on.
Or alternatively, you could use a different colour chalk. We could put it
Yeah.
on.
I think something's gone with those. Let's try light green. Okay, and I think you don't really need to. It would be good to have some people who on the project who know about those things, but you don't have to be a Python expert or anything. It could be a chance to learn some more Python.
No, the Python will be very simple. I think you would do that. The Python will be very simple. The Fortran is also relatively simple. And there will be scope for people just sort of to discuss in terms of how this would be used. So if you just got a general simulation background, then just saying, actually no, I think that would be clumsy for us as application designers to use. That would also be useful. So you don't need expertise in any of those languages.
Yeah. Now, it's also worth mentioning that some of you weren't here for that part of the summer school, but fear not, because there is all the slides and things over here. It was in the bridging Fortran and Python for ML parts. You can go into the resources and review those at some point before tomorrow. And yeah, there's a bunch of stuff already there to help you sort of understand. Okay, cool. Thank you so much, Simon. And let me just say before we do the rest of the pitches, if you go to the program of the summer school, there's a join hackathon team link here. It's just a Google spreadsheet. And we've got teams across here, and you just put your name in on this list going down if you want to sign up to a particular team. And after this, we're going to go into MR4. There's going to be a wine social. There's some of the posters out from the summer school. You might want to start sort of going and introducing yourself to the team leader and saying, hey, yeah, I want to do this, having a little bit of a chat about it already. What we'll do in the morning at 9 o'clock in FW26 in the computer lab is have a quick, these were the teams again, team lead wave, and sort of a quick reminder about everything first thing in the morning as well, if you're still unsure which team to be in. Cool, okay, people are interacting with that. Right, who wants to go next? Raphael?
Can you hear me?
Yeah.
Okay.
All
Alright. Yeah. So, have you heard of Next Sim, the CS model?
Yeah.
Okay. Cool. So yeah, it has been deployed in the European clusters, and also run. It also has some configurations of attached CIs. A colleague of mine, Guillaume Boutin, implemented the first Antarctica configuration of NextSim. but also in a French cluster. So what we are trying to do is like to have also Antarctica simulations of next sim in New Zealand clusters. So if you're interested in help me running next sim simulations in New Zealand cluster, come and join me. There'll be a bit of first installing, running and validating the model, a bit of Bash, Python, and the model is built in C++. So,
cool. So I called this on here. What did I call it? I called it Next Sim for NZ.
That's great.
Is that okay?
Yeah.
All right.
Next scene for Kiwi.
Oh yeah.
For what?
Next scene for Kiwi.
For Kiwis. For Kiwi. For Kiwi. Okay. Yeah. I'll update the spreadsheet in a moment. So, okay, so that was Bash, clusters, some sort of Python, let me just write Pi, and C++. I think probably not like much writing of that, or maybe just sort of poking sort of bits of that a little bit. Yeah. So, you know, if you're interested in how code gets run on massive clusters and like configuring things with Bash, build systems and things, that'd be great, and it'd be very useful for your work, right? Cool.
Yeah, cool.
Okay.
All right.
Thank you.
So let me update that. Next sim for Kiwi. So someone proposed something that I've called Geograph. Who's the Geograph person?
Probably me. I
Okay.
didn't know that was already submitted to be one of the projects, but I'll give it a go.
It's on the list. Right, do you want to introduce yourself as well?
Yes, I'll do that. Can I take the mask off? Or?
Yeah.
Lovely.
Yeah.
Thank you. Can I use Chrome on here?
Sure.
Maybe if I have a visual, it might be easier to show. So hello everyone, I'm Simon and I'm part of the AI for RCDT here in Cambridge. I haven't been part of the summer school yet, so I didn't get a chance to meet all of you yet. But I'll be here tomorrow and a bit of this afternoon, or this evening. And it's lovely to see you, very interested to hear kind of what you've all been up to. In the AI for RCDT, we're interested in looking risks related to climate change in general and trying to use methods from the artificial intelligence community to better understand those risks. And as part of that effort a year ago, as a group of, I think, 5 people, we started a project called Geograph. I'm just going to show you the repository here now. And what it does is it's a tool to investigate landscape fragmentation, and then by extension to use it for analysis of habitat fragmentation of different species. And it's a nice tool, but as you might be able to see, so it's got all of this kind of graphics about it to use essentially graph theory, to do a bit of analysis of all connected components, and then use satellite remote sensing data to turn it into this data format. The problem with it though is, as you see, it's not very actively maintained because most of us have gone on to do their PhDs. But it is a very interesting tool for the community, and so we thought it could be cool to spend the day tomorrow with a group of interested people to bring it essentially to 2022, where we are now. And there's a bunch of things that can be done on documenting and using it for use case, and also on essentially code improvements. And we've got quite a bit of this branch stuff and software engineering stuff that you were telling us about before. And so yeah, very happy to work with anyone interested in that.
Does it have any tests?
It does have some tests, but I don't think in the main branch. So that can definitely.
And do they run automatically on commits? I don't see.
They do not run. There's no automatic.
That's something we've learned about.
There can be something we can add tomorrow. Yeah.
Yeah. Okay.
Because we do have some sample structures. So we do have a binder that if you launch it, you can run with some sample data that is in the repo, and you can play around with it, but it's not in tests.
Okay. So that's Python. What else should I say about this?
Landscape fragmentation from kind of the application side of view. I guess software engineering, because it is a deployed product.
SE software engineering. Yeah, cool. Okay, and that's with Simon. So if you add yourself into here in the team, then go and do it. No, you can do
I'll do
that.
it.
Yeah. Great. Okay. Oh yeah. I'm sorry. Yeah. So Simon, thanks. Yeah, I should have said a bit more about this beforehand. So thank you for mentioning that, Simon. So yeah, for the rest of the people in the Soul School, you probably heard that AI for ER CDT mentioned. That's a big acronym. CDT is Centre for Doctoral Training. It's like a PhD program where you have 1 year master's training followed by the 3-year PhD program, or 3.5 or something like that. I don't know what it is. 3.5? 4?
Still up. Still depends.
It depends.
We have anyone who finished it.
Yeah, it's still. I mean, it's only been going a few years, so yeah. So Emily Shuckborough, who you've met several times now, she leads that as well. So we invited the AI for ER students to come and take part in the hackathon and the summer school. So you've probably met some of them already, but yes, we've got more of the CDT students here, which is great and welcome, and yeah, great to have you involved in the hackathon. Okay, who's the next pitch?
Sorry, I have a question. Which
Yeah.
languages are written by geography?
It's all Python. Any particular libraries you want to mention that it uses? Or?
NetworkX, Shapely,
Shapely.
Raster.io, right?
Yeah. Okay.
iWidgets. Yeah, iWidgets for the UI.
Okay. So iWidgets, Shapely, what's it called?
Rasterio.
Rasterio. That's it. Yeah. So kind of quite popular in geospatial things.
Lots of geospatial.
Lots of geospatial stuff. Yeah. Cool. Who's next?
Ryan Abernethy.
Ryan. Okay, yeah, okay, so I'm going to invite that over here. So Ryan gave us this talk earlier, inspiring talk about sort of library infrastructures for science. He talked about the Pangeo project, which hopefully I should be able to find quickly here. This one could be trickier because we don't necessarily have a lead, but
Quite a few nice issues.
which repo is that, Simon? Is it just the Pangeo one? This is Pangeo website. Okay, one moment. Do you know which one we're looking at?
The last you mentioned was about filters, but I don't know if it was.
Wasn't it XGCM rather than Pangeo?
It was X Batcher.
It was X-Factor, yeah, that was it, thank you.
I don't think it was still on Pangeo.
Okay.
Xarray-Control expansion.
Yeah. Right, so this is batching of massive X arrays, and it has a bunch of issues on there. This is a community code. It's used in lots of general circulation model style things, lots of climate model work, analysis work. So it's got a whole bunch of issues which have quite a lot of, no, not that one, which tend to have quite a lot of useful explanation. You know, these are not just this thing is broken. there's some decent explanation on these things here. So this is all Python. So here's X. And this is sort of Python, X-array kind of thing. So if anyone wants to take a look at that, and we can get the slides from Ryan as well, to put those on the resources if that would be helpful. Okay. Ben?
I have one, but mine's on. I don't want to come up right now. Mine is on Next Sim. I chatted it over with the RSEs.
I think it is the same as the second one.
It's the same. I knew it was very similar. So
Okay.
and now seeing that we've got 4, I'd like to retract.
Okay.
because it wasn't so interesting. It was writing. It was a smaller focus thing than the more interesting project we have here.
Well, it could be absorbed into that as well.
I think it could be, yes.
Okay. Yeah. All right. Do we have any XGCM one as well, or perhaps we can have a think about that? We've got 4 so far. 4 is good. Okay. Anyone else want to pitch something? For example, maybe there's something you're working on right now. Maybe there was some code you were doing this morning, or that you're going to do tomorrow morning, and you're thinking, wow, it'd be so great to have someone else help me on this.
Well, a different thing that I hadn't previously suggested, because it's shoving my work into the hackathon, but previously I've talked with Ryan, and he wanted to. Should I come up for this?
Yeah, go on. If you're making a pitch.
Yeah.
Right. Ben's making a pitch.
I previously talked with Ryan, and specifically on the XGCM library. So it builds on top of Xarray with just lots and lots of metadata, and one part of the library is it understands some common conventions for labeling large data sets. If I'm remembering right, they're called the Komodo conventions. They're a bit hard to Google nowadays because they're somewhat apparently a little bit outdated, and they are, there's an alternate set of conventions for labeling and laying out your metadata, which XGCM doesn't yet support, but Ryan and the XGCM team stated that it would be very useful if someone could get some work started on that. What, Dominic, do you remember what they are called? Is it SGRID? SGRID conventions.
I remember it had S in the title.
And I've looked a small bit into this, and we've had discussions on what the changes might look like. But I'm not so clear on kind of the usage and the situation of the Komodo conventions themselves. So I haven't seen too much like sort of example usages of Xarray and XGCM. So I would love to take lead on this, but I might need some support from perhaps if there are any users of Xarray or XGCM or folks who have seen or come into contact with S3 conventions or the Komodo conventions.
Okay, great. And so there's some stuff sort of scoping that out already on the GitHub that you could sort of digest a bit and sort of talk through with people. So what are we calling that? XGCM SGRID?
Yeah.
So that's Python, Xarray, sort of it's kind of geospatial stuff again. Well, it's quite general sort of array stuff. I don't know, Komodo. Okay, thank you. Could you put that on the spreadsheet as well then?
Andy, should I just add it to the
Add a column for it. Yeah. Okay, anyone else? Anyone else want to pitch something they're doing, perhaps from their work, perhaps from their previous projects? Just thinking about some of these, maybe there's also ways of breaking some of these things up. So some of the very general sounding projects, like X-Factor and Geograph, there might be ways of, there's sort of lots of things potentially to do there. So they could also be split, right? So we could have 2 teams perhaps doing different things on them. So we can think about that. We'll see how it goes, but we'll consider that. If you could think a bit about that, Simon.
Absolutely, yeah.
Yeah.
I wasn't sure whether it was part of being accepted for the pitch ideas or not, because when I read the form, it read a bit preliminary. So now that I know it's accepted, in a sense, I'm happy to do some more detailed scoping.
Yeah.
So if I'll have some time to think over it.
Yeah.
Tonight or so.
Yeah, okay, so we could sort of...
Substream, depending on how many people are interested.
Yeah, I think we'll see who signs up, and then we could always split it tomorrow. We do the session in the morning, we can figure that out.
That's fine.
Yes. Jack, do you want to make a pitch?
Yeah, I can add one if it helps bulk it out a bit.
And then we can go and have one.
Hello, so I've only really been thinking about this since lunchtime, chatting to Dominic, so it's sort of quite fresh, but essentially what I've been working on is we have, the Earth has a magnetic field, which hopefully isn't a shock to people, and we commonly think of this at the most basic level as a dipole, but actually it's much more complicated than that, and we have models that are better than a dipole, but these are driven by various parameters coming from solar wind indices, this sort of thing. And we are interested in being able to forecast what this field is going to do. So people probably saw in the news, Elon Musk chose to launch all his Starlink things into a solar storm, and half of them fell down. If he listened to forecasts, that might have happened. But people can't do this at the moment. So the question is, can we predict what the magnetic field is going to do over the next hour, day, week, maybe? So I've got a data set that has sort of a long time history of these driving indices. And I thought, one thing I thought of is it might be interesting to see, can we do some kind of time series forecasting on this? I'm open to how this is done, so whether people want to try using some of the scikit-learn packages to do some of that, or whether people have other ideas, want to try and do something more physics-based. So it'd be a bit of data science, and I would want to put this on a GitHub and exercise sensible software engineering practices that have been talked about. So yeah, if anyone's interested, let me know.
Cool. So what should we call that, Jack?
Forecasting magnetic fields.
Let's call it geomagnet.
Geomagnet.
Needs to be short so we can remember it.
Geomag is trademark.
What?
Didn't you play with them as a kid?
No.
No what?
Geomagnet forecast. Okay, so that's probably Python, scikit-learn.
Oh yeah, sorry, I should say it's all. I've got a few scripts that I'm on GitHub, and it's all in Python.
Okay, so it's already a good basis, and maybe some. I'll just put ML.
Yeah, and yeah, I have no great experience with machine learning, so for someone who knows all about that and wants to give it a go, that would be good.
Great. Okay, perfect.